underwater volcanoes. How ocean color changes can signal an imminent eruption. I have to correct myself. The previous Tonga volcano eruption video I posted, I told you that the eruption level was 3 out of 5. It's not. It's still 5 out of 5. It's still erupting violently. Now, this is by Matthew Blackett, reader in Physical Geography, Natural Hazards, Coventry University. Coventry University is in the city of Coventry, near Warwick University, where my son went to university. Beautiful landscapes there. And Lady Godiva's city, Coventry. Okay, this is on the conversation. So he says the scale of the recent volcanic eruption took the people of Tonga by surprise. Scientists monitoring the submarine volcano, the underwater volcano Hunga Tonga, Hunga Hupai, are likewise caught off guard, failing to foresee an explosion which would unleash a Pacific-wide tsunami. So, of course, underwater volcanoes, there are plenty of them, especially in the Mediterranean. For every volcanic island, they say in the Mediterranean, we have 10 underwater volcanoes that nobody knows what's going on with them. And we have had a lot of activity, geological earthquake activity in the Mediterranean. 4 magnitude, 5 magnitude, 6 magnitude earthquakes. That's not good. The geologists are saying that the area underneath the sea is filling with magma. So this is one of the things that geologists really can't predict, when an undersea volcano, an underwater volcano, a submarine volcano is going to erupt. They have no GPS stations there, and they don't know what's happening underneath the water. So the scale of the eruption was hailed as a once-in-a-millennium event by one scientist. It hurled gases and ash over 39 kilometers into the atmosphere, so that's basically into the ionosphere where the ISS is. Now, comparable to that ejected from Mount Pinatubo in 1991, the generated a shock wave that was heard in New Zealand and detected as far away as Switzerland. Of course, even Alaska detected the shock wave. Scientists estimate that the blast may have been the loudest terrestrial event since the eruption of Krakatoa in 1883, while an organization which monitors nuclear tests went so far as to declare it, quote, the biggest thing we have ever seen, end quote. Ash covered homes in Tonga 3 days after the eruption, according to EPA, the sat images. And we know that the ash plume of this eruption is now headed, it has gone across Australia, it has gone across the Indian Ocean, and has now reached Madagascar, and is now heading over eastern Africa. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box. The volcano had been active a few times in recent years. The moderate eruptions that only amounted to local disturbance, the lack of warning for an event this large left many wondering if there might be other volcanoes beneath the ocean similarly primed to blow. Well, of course there are, especially in the Ring of Fire. Now, we're talking about the Pacific Plate. To study volcanoes and interpret whether they're likely to erupt, scientists mount them with different kinds of measuring equipment. Seismometers help them detect small tremors caused by magma moving under the ground, while gas samplers and thermal cameras can be used to track changes in gas concentrations and temperature as magma ascends from the depths. It's rarely acknowledged, though, that most volcanic activity on Earth occurs beneath the sea. Submarine volcanoes are pretty much ubiquitous in all of the world's major oceans, and it's estimated that 75% of the Earth's magma output comes from mid-ocean ridges. To make things trickier, many known submarine volcanoes are found far from land, and being underwater prevents scientists from observing any changes by conventional means. So how do we monitor underwater submarine volcanoes? Scientists have managed to install equipment that detects telltale tremors on the seabed before. This research has helped reveal the seismic precursors of a submarine eruption, the signs that one is imminent, similar to what scientists had already documented in volcanoes on land. Installing this equipment does not come cheap, though, and it's not possible to do it everywhere. An impending eruption can be detected in subtle temperature increases on the volcanic surface. For submarine volcanoes, these are harder to spot. The heat signatures of submarine volcanoes will only ever be visible at the sea surface if the volcano is in shallow water and already erupting hot lava. At that point, it's too late to warn anybody. To really find what submarine volcanoes are up to, it helps to zoom out, way out. So you can monitor this from space. Monitoring for space, satellite observations allow scientists to regularly view vast areas of the ocean surface, helping them note any changes. On numerous occasions, scientists have spotted floating rafts of pumice rock, which can be traced back to submarine eruptions that might otherwise have gone undetected. But this only allows us to identify eruptions after they have happened. It does not help us stay a step ahead of underwater volcanoes. Recent scientific advances can, however, in the early 1990s, Japanese scientists investigated a long-noted phenomenon, the strange discoloration of the ocean near submarine volcanoes off the island of Iwo Jima. They determined that it was caused by precipitations of silicon, iron, and aluminum oxides emitted by underwater volcanic activity. Later work confirmed that a higher proportion of iron precipitates produced a yellow-brown hue, while higher proportions of aluminum or silicon result in a white color. Scientists revisited these findings during submarine eruptions around another volcanic Japanese island, Nishinoshima. In satellite photographs of Earth's surface, the ocean was seen to turn varying shades of yellow, brown, and green, depending on the ratio of silicon to iron and aluminum. Now, this is a fun thing to watch. Bubbles coming out from the sea. We have a lot of underwater volcanoes in Greece, in the Aegean Sea, and we have many such bubbles coming up from under our feet as we swim. You can even feel the heat from these bubbles, and you're saying, oh, that's nice. I'm getting free water, hot water from the spas coming out, the spring baths coming out from the volcanic areas underground. So this is not an unusual sight in the Aegean Sea of the Mediterranean around Greece, these bubbles, because of the volcanic islands. So here they're talking about the discoloration of the water, or the coloration of the water. The thing is, you have to be there to see it. If it takes place and you don't see it, what use is it to you? Now, with this finding, though, scientists discovered that the color of the ocean began to change about a month before the submarine volcano erupted in Tonga, and this suggests that ocean color may be a reliable precursor of underwater volcanic activity. And given this insight, there is every possibility that in the future, automated systems could analyze satellite images of the ocean in volcanic regions for sites of an impending eruption. The destruction wrought by the submarine volcano, the eruption of Hunga Tonga, Hunga Hapai, appears to be intense. It's still ongoing, as we said. And the ash plume is now heading towards Africa. This is what? It's a week later. So in another week, is it going to go across the Atlantic? That's the next question. Now, because obviously this eruption is still ongoing. Code red, 5 out of 5 level, according to Volcano Discovery. Now, going back to this article, the tsunami that followed obliterated coastal areas of Tonga and even caused victims thousands of miles away in Peru. Ash coated the island, destroying crops and shutting down transport networks. Had an earlier warning been available, perhaps on the scale of weeks, as research suggests might be possible one day, it would have let people on Tonga stock up on food and water and evacuate vulnerable regions. This once-in-a-millennium tragedy might at least stimulate further research into monitoring and predicting the ever-present hazard of submarine volcanic eruptions, he says. and this is on the conversation. There's not much you can do about this except evacuate people. Trying to predict beforehand, before it happens, before it's too late. Please leave your comments and thank you for your support.